Backed by popular demand, we have more squares to test.
Now, inside this box is a set of square frames, but why are these ones so important? Well, let me tell you a story. This all started a few years ago. I made a video where I built this frame while using a fixture table, and it made the job faster, easier, and more accurate. That video got a lot of people talking, and some of you said that you can build just as well on a regular steel table, and that you don't need a fixture table at all. So, I wanted to see if that was true. I took my frame plans and went undercover. I hired 3 different shops, each using a steel table, to build 2 identical frames. They followed the same plans, or at least they were supposed to. When I got the frames back and tested them, none of them matched the plans. And that got me thinking, were the frames too simple, so they didn't take them seriously? To find out, I made the plans even more complex. This for sure would have made them take this project more seriously. So I hired 3 more fabricators, but they still got it wrong. That sparked even more debate. Some of you even thought I said it was impossible to build these frames on a regular steel table. But I really said, making a perfect frame is virtually impossible. But how far from perfect are these frames allowed to be? And some of you took this as a challenge, followed the plans, and built these frames on your own plate steel tables. And one of those people was Scrapman. Scrapman, also known as Dalton, is a welder from Ohio with over a decade of experience. He started on YouTube, teaching viewers how to fix things. So, after seeing others struggle to meet specs on the frames, he decided to try it himself using his plate steel table. Then a few weeks ago, Dalton reached out to me on the Fireball forums, asking if I could grade his frames like I did for the others.
The Fireball tool guys see this. If you want to check them out, let me know if they pass. That'd be pretty cool. I would appreciate that.
So I said yes, of course, send them in. And these are the plans that Dalton and the original fabricators worked off of. I need 2 identical square frames made from 2x2 square tubing. The welds should be ground off on one side. They must be 20 inches by 20¼ inches max, with up to 1/16 of an inch undersized. Plus, they need to lay flat with only 1/16 of an inch of wiggle room. All corners must be 90 degrees, no crooked shapes. And if the frames don't match, it's an instant fail.
But I'm pretty confident that he did it correctly. But what's missing from that equation is time. So just how long should it take to make these 2 frames?
According to Scrapman himself, it took nearly 3 hours to complete these parts. If we remove material cutting time, that leaves 2 hours to create these 2 frames. This is about how long it took the other fabricators to make the frames. Is it reasonable for it to take 2 hours to build? But here's the thing, I'm not going to put tight tolerances on drawings that I know I can't achieve right here in this workshop in a realistic time frame. So I'm not going to judge Dalton's frames just yet. Instead, I'm also going to build them myself, but I'm going to see if I can do it faster using a fixture table. And then we'll grade our squares side by side. So here are the rules for my little game. I have 2 hours to build the frames from my drawings. The timer starts the moment I take the first tool off my shelf. I can't stop the clock until all my tools are put back where they belong, my table is clean, the frames are checked to make sure they're good, and are sitting on my table.
Also, to handicap myself a little bit, I have included a bad part in these 8 pieces. Which one is it? I don't know. I cut it long and I threw it in the pile. We're gonna have to identify it as we go.
I hear a lot that fixture tables are too expensive and nobody can afford one in their workshop. Well, for this game, I'm gonna do it on the cheap. So I picked up this cheap welder and I'm going to be using this new Fireball DIY table. This is one of the cheapest tables in our arsenal, which is a little more than 600 bucks. And with the fixture table, I can utilize these low-cost universal fence blocks. This whole setup right here is a little over 1,000 bucks. By the end of this, I think we'll see that with the right tools, you can build these frames fast and accurate without spending a ton of money. There's only one way to find out. We gotta build it.
Okay, we're gonna start at 8:55 and we'll monitor the clock. But I'm also gonna have the editor put a stopwatch down at the bottom so we can keep track of time. So I have my tools behind me, which normally live on this cart. So there's no cheating, no pre-setup, there's no nothing. 3, 2, 1, go. Okay, the first thing I'm gonna start with is a set of fence blocks. So these are super cheap. Now what I'm gonna do is give myself a reference corner. This is pretty standard procedure for every single build. Starts off with these things. Just gonna start laying parts in here. Okay, I'm gonna put 2 clamps on every one.
While I'm getting my pieces ready to weld, let me tell you about the table I'm working on.
This is a precision piece of plate steel that has been ground on both sides. It has precision machined drilled 3/4 holes. It has a unique plate steel leveling system that straps the plate to the frame instead of welding it. This allows precision calibration of the surface. Then topped off with an extra layer of protection with dragon scale.
Now with our assembly complete, we can get to welding our first frame.
Now we go through the trouble of getting this one set up. Let me see. Whoa, yeah, this one's super long. So the fixture table is really good at giving you a quick visual check of squareness and dimension. And I really like that. I think that's probably the best scenario to check for quality here.
Thanks to the fixture table, we now know the dimensions are correct, so we can start welding together the second frame. Another benefit of this table for me is the size. I enjoy working on a small table for small projects, so I don't have to reach across a big table to weld.
Okay, we put all the clamps away, then we'll clean up, and then we'll call it time. And that was what, a minute and a half. I'm gonna do a quick inspection one more time. Technically I'm done, but I wanna check. There's a teeter-totter there, maybe a little bit. Just a skosh, ever so slightly. Probably less than 0.010 of an inch. I guess we can stop the clock. It's 9:26. Machine's turned off, cleaned up, parts sitting on the table.
It took about 30 minutes to make and check both frames using a fixture table. But don't worry, just because you do it faster doesn't mean you have to charge less money. You can still charge for at least 2 hours of work, just like other shops do. This way, you make extra money and have more free time, so you can take on another job or even go and relax.
Okay, now the only thing left to do is check them to see if they pass. There's his welds, there's his grinds on each side, just like we asked for. Is there anything in it? That's a good sign. How about this one? Maybe a little something in there.
This one, it does have some sound in it.
That's okay, that's acceptable. Nothing too crazy though.
The first thing we need to measure is flatness. This is one of the things that gets overlooked the most. This is the hardest dimension to maintain. Without the right tools, this can be hard to measure or identify. I've called out for a 1/16 of an inch tolerance on this frame. I'm going to be using my Starrett granite surface plate to measure the swarp. It's going to help you and I identify if there's any problems with this frame.
We're looking for teeter-totter, and the goal here is that we're not supposed to be able to slide a 1/16 of an inch shim underneath any of the corners if you push down on it. So first test is we're just going to listen for teeter-totter. Just a skosh there. Just from doing this enough, I know that this is probably going to pass. 1/32. Nope. Underneath. So this is pretty flat. Good job. Okay, second test. Ooh, this one's got some teeter-totter to it. Let's see if a 16th will go underneath. Nope. Barely. But technically this does pass the flatness test. Okay, let's do the sound test. Okay, got a little noise there, which is really good. Obviously, a 16th won't go underneath there either, obviously. This one's exactly the same. Let's see if a 16th will go underneath there. Nope. It does not. Good results.
The next thing I am testing for is squareness. So we're going to use the fixture table to do that. It's the best way to check all the sides together. If it's not square and the dimensions are off, then the fixture table will tell us that.
Ooh, man, that is tight. The plans call out for a maximum of 20 1/4, and seeing that this is having a hard time getting down there. So this is a 3/4. This is the maximum measurement, and then when I add this 1/16 of an inch shim in here, this would be the minimum measurement, which means this should not drop down inside of here. Ooh, man, he is really, really close, but so far passy. Okay. Let's see, we're at the right way. Fitting okay here. Once again, not so, looks a little tight, but we'll confirm that with the caliper.
With the caliper, I'm going to measure Dalton's second frame first because the fixture table told me it was likely the right dimensions.
Damn near right on the money on that long way. Pretty dang close. Center obviously is pretty good. 250, pretty good. And pretty good. This one passes.
With that frame all clear, let's move on to Dalton's other one, which gave me some concern on the fixture table.
Within 3, yeah, that kind of confirms what we see, 22 thousandths oversize in this dimension. So technically that's a fail. Okay, here's mine. And there we go. And that fits. This one feels pretty good. Looks pretty snug. Snug in a bug in a rug. It fits, but we'll have to see how close we are. It's a little tight over there, but it does go. Right on the corner. Cutting it a little close. In the center, had that much of a bow. Let's check the other dimension. Well under. That passes. That also passes. Okay, part number 2. Okay, that's within spec. That's also within spec. It should. Yep, and this side is under 10.
By also passing the dimensions test, this means that both my frames are also identical, a requirement I laid out in my drawings.
Well, Dalton did pretty good on his squares, but we do have to deliver some bad news. And nobody really wants to do this. It always makes me uncomfortable having to tell somebody that they failed something, but we got to do it.
Dalton,
Hello?
can you hear me okay?
Yeah.
Can I ask you, how do you think you did? If you were to give me a score from like 1 to 10.
Probably like an 8 or a 9. I mean, I spent a lot of time checking those things as well. I think it to spec at least.
Did you think that the drawings were easy to understand?
The drawings that you had were actually like probably some of the better drawings that I've seen. Usually I don't get drawings, you know, it's just people are just like, you know, I want this to look that shape. And I'm like,
yeah,
I don't know what you mean, but okay. So having drawings, especially to the level that yours were at, was definitely a good thing.
Did you happen to see the earlier videos where I made the square and then I hired somebody else to build them?
Yeah, so I watched those ones, and it seemed like a lot of people that have like bigger shops and more tools than I do tried to do that as well.
Because I paid the other fabricators for those parts. What did it make you feel like inside when the parts came back and they actually weren't to the tolerance that I had drawn?
Yeah, I mean, that's definitely on the shop.
If the shop said, well, to hold these tolerances, I'm going to charge you more, and I would have been okay with that.
Yeah.
The fabricator sees that the tolerance is high and they need to have a special tool or equipment to hold those tolerances, then I think I should be charged more. I think that's okay. Tighter tolerances require more precision, potentially. How long would you say it took you from start of the project to finishing? Minus cutting the material.
Probably, I'm going to say at least 3 hours per square.
Oh, wow.
Yeah, that was mostly just clamping and banging things around. And then I had to grind off pieces that were too long or whatever and redo everything and measure it 3 or 4 times. And then I had this glass picnic table out here that I used to check for the flatness. I mean, that's the only thing I have that's even like relatively flat. And then to double check it, I wanted to use the plumb bob string that I have to go from like corner to corner. And then when the strings kind of like try to occupy the same space in the center, that's how you kind of know it's relatively flat. If I was building to tolerances that tight every day, I mean, there's no way. That was an aggravating experience. But then, you know, there's a lot of situations that could arise where you definitely do need a tight tolerance like that.
I guess now is the time that I'm going to give you your results. Now, I know you took a lot of time on the flatness because I watched your videos. You passed on the flatness. I'm really impressed with that. That is absolutely probably the hardest part because it takes some special tools, and you did very well. Okay, how do you feel about that?
The flatness was probably the thing that I was most worried about because, like I said, initially, the table's not flat. I definitely wasn't building on anything flat. Having a table that's super flat is definitely nice. But if you don't have that, at least have the skills to be able to check it some alternative way.
So either the tools or the skills to be able to check for that. Yeah. That's absolutely. And the fastest way possible is always going to be the most profitable for sure. Okay, so our dimensions that we were trying to go for was 20 and then 20 1/4. On one of the dimensions, you got right, 20 inches. But on one of the other dimensions, you were 22 thousandths too big.
I mean, I'm definitely happy only being 22 thousandths out of spec using
Yeah.
the tools that I had to use.
You can't see 22 thousandths with a tape measure. I'm nitpicky. You proved it. You can get pretty damn close. But it's the time that's how you make money. I think that's an element to this whole equation that we really don't talk about that much, is the speed.
If I had a fixture table, then yeah, it probably would have been about a 20-minute ordeal. I've definitely been like eyeing up some fixture tables for a while now. It's kind of like if you're in the business of digging foundations for buildings. If your boss comes to you and says, hey, we need to dig a foundation, and he hands you a garden shovel versus a backhoe, you're going to be like, like what the heck? It's kind of the same thing. Just, like a fixture table is the backhoe, I guess. It will make you put out better quality parts in less time with less skill.
I can see that you understand the benefits of a fixture table. I want to see you be successful. I want to see you excel in life and in your adventures and in your business. As a thank you for participating with a little fireball challenge, I would love to give you a fixture table, probably a Dragon Wagon or a DIY table of your choice.
I don't know the words I'm trying to say here. Thank you.
Thank you for being a part of this project. I look forward to watching more of your YouTube content and seeing what you make with it and following your journey. And I know the other viewers that are watching this would like to see you be successful also. Thank you again, Dalton, and I'll talk to you later. Okay, bye.
Here we are at the end of the video, back to square one again. 2 frames that have not been built to the drawings. I'm not saying it can't be done, but I'm unconvinced that it can be done as fast and as quickly as a fixture table. And here's how I want you to convince me. Make yourself a video of you building 2 perfect frames on camera. And here's the set of rules to do it. You're gonna start with your blank plate steel table. All your material needs to be sitting on the corner. Set up a tripod and camera in an isometric view so the entire build process is in view. There needs to be a clock in frame, and you have less than 30 minutes from start to finish. Any traditional measuring tools are allowed, but if you want to make something custom on your own, you must have it done within the 30-minute window. If you're that type of guy who likes to weld stops to his table, that process needs to be applied and ground off in that 30 minutes. And grinding down all the welds on one side, plus the quality control test, needs to be done in that time as well. If you'd like to send in your results, you're more than welcome to upload it on YouTube or send us a thumb drive with an unedited video. If this was all too fast for you, I'm gonna leave the instructions down in the description. I'm also gonna put them at the Fireball Tool forum along with the plans. So if you can build these 2 frames on a plate steel table accurately in under 30 minutes, then I think you can convince me. But until then, you're gonna have to prove it to me. So I'll see you on the next one.